honored to be here, and it's been fun to look at the work of others, and now I'm in a position to think, what am I going to say about my work? So I can modify at a moment's notice. But when you come from Portland, because we're so strongly associated with the green infrastructure movement, I thought, well, maybe this is an opportunity to kind of look back at our involvement in it and see if we can kind of claim a spot in having pioneered a thing or two. And I'll have to say, strongly building on the work of Tom Lipton and the late Robert Morassi, who worked on the Oregon Museum of Science and Industry, and I think Tom will be talking about that later this afternoon. So Portland's a very tight design community, and we learn from each other. We influence each other. We get to see what each other's doing, and I think you'll see a bit of an evolution over the time that I've been working on this since about the early 90s. So we always ask ourselves, why does stormwater matter? You know, and one person mentioned that, you know, airborne pollutants that fall on surfaces, maybe roofs are cleaner than streets. That's definitely true, but I contend that airborne pollutants fall on all urban surfaces, rooftops, streams, streets, parking lots, paved surfaces. And actually, you know, a good example is look at your car. If you go away for 2 weeks, you washed it before you left, you come back, it hasn't rained, and it's covered with sticky stuff and, you know, things that have fallen out of the air. Some places are more dirty than others from the air quality. You'll see from this example, this isn't the picture postcard for Portland, Oregon, but it is Portland. And that, you know, freeways and all the rubber and all the airborne pollutants that come off fall onto rooftops in these urban areas. So we don't take those rooftops for granted. We feel like those need to be treated as well. And I want you to just make a mental note. This is a project I'm going to show you a little bit later on, and you won't see the context of it next to the freeway in my photographs, but just remember that's what's there. So when I teach stormwater classes, I always remind everybody of the principal contaminants that we have, none of which are particularly pleasant to deal with. Some are in greater quantities than others. And not to mention trash, too, because when I talk to students, I say, you'll never look at a catch basin in the same way after I'm done with you. You will never walk past one, and you'll see those pools of oil and the pretty colors, and you'll see the sediments, and you'll see all the junk that goes into our rivers, and most of it is untreated. So, and then coming from Portland, people always say, well, yeah, no wonder you have so much stormwater out there. You've got so much rain. Well, in fact, maybe we don't have as much rain as someone might think. Maybe Philadelphia has more. I got it off the internet, so it must be true. But we also know that Denver and Los Angeles have far less rain than Portland, but I say, are your streets any cleaner than ours? Yours just don't wash off as often. You're not as reminded of water as we are in Portland, Oregon. So yeah, we were a little more proactive at getting there in terms of dealing with it. And we have endangered species of fish in our rivers. So we're taking this all very seriously. And stormwater does remain the largest non-point source of pollution in our cities, according to the EPA. So as a firm, we've always looked at how can we best integrate the science and art of stormwater design, and how can we apply artful stormwater to a variety of projects. I'm going to go through these really quickly because there's a whole host of projects coming up, not just a few, and try to imagine the different circumstances under which we're working on behalf of stormwater, both storage and delay of the water post-storm, and also the water quality. So back in '96, we had our big first job to really think about stormwater. And we said, well, we're not really sure what we're doing on this yet, but we do know that we're going to have a lot of parking lots. And we concentrated on those parking lots in this master plan. And each parking area has bioswales, and we weren't really sure what to call them. Were we calling them bioswales in '96? I guess we were. Yeah. Okay. Yeah. And so we designed them. We made the water run downhill. We worked closely with the civil engineers. We also looked at the idea of wet ponds and dry ponds. A wet pond being one that holds water year-round, and a dry one that's more seasonal in nature. And it was particularly important on this campus to keep those particulates out of the waterways because these are the headwaters of streams that salmon spawn in, our endangered species. So we took this assignment very seriously. And the first thing we did was, I believe we called it a grassy swale. And I remember standing out there after it was done, and we looked at it, and the former farmer who owned the site was there, and the civil engineer, and the owner, and the maintenance people, and we looked at it. He goes, "That's nothing but a damn farmer's ditch." And I said, "Well, actually, you're right, it is." But look what it's doing. It's really capturing that sediment. And now this is overgrown with lots more vegetation, as you can imagine. But it was a kind of excuse the pun, a watershed moment for all of us to realize that this technology is not new. And farmers have done these sorts of things for years. And then this is an example of putting that wet pond right in the middle of campus where everybody sees it, where it gets good maintenance and it gets a lot of attention from students, and particularly the biology students. So from there, we were doing other smaller experiments along the way, but we felt that maybe our work at Nike could have some of the same kinds of water goals that other projects have. This one wasn't highly regulated, but it certainly was a goal of the campus that we were working on, this 90-acre north area, to be able to use the parking lot runoff in a treatment facility along this area and over in this area as well. So all of the parking in here gets piped to these small ponds, and Nike came to us and said, "Well, are you sure you want to do this? This might be ugly, or it might not work," or all the things that a good client questions. And we said, "Well, we've tried it on a smaller scale before. I think we can do it here." And we had the assurance that the civil engineers were very sharp in their game too, working closely with us. And sure enough, in some cases there's a very small area to be used, and in some cases it's much larger, but that we could really start to have an influence not only on the water that runs off the Nike campus, but the water that enters it in the forms of streams coming off campus. And it really is quite attractive. This is probably like early March when things haven't really leafed out yet. And sure enough, if you build it, they will come. We have found snowy egrets and all kinds of waterfowl on the campus that hadn't been there previously. And then it turned into an interesting sort of idea from SalmonSafe, which does certification of campuses in terms of their policies and their practices toward cleaning water. And it became a marketing thing for Nike. They said, "Wow, this green movement that we're talking about, this sustainability stuff that we're talking about gets us good press." And they, as a corporation, started to change a lot of policies, really have had a large effect. There goes the Eastbank. So I'm going to switch to the Eastbank Esplanade, and that's the one I wanted you to look at early on when I was first getting started, and that's the 1.5-mile trail that's next to the Willamette River, and you always know how to say Willamette because you say Willamette, damn it. You don't say Willamette or some other variation. People will know you're not from there if you say Willamette. And then the freeway is right on this other side. So it's a very narrow strip of land, very challenged in terms of width for pathway, and in some cases going out over the bank just to try to get a little bit more space for the trail using graded structures. And in some cases, the trail floats on the water. There's a section of the trail that gets people right next to the water. So whatever's going on with the water, you're part of it. You can feel the surge of it. There's over 30 feet of elevation change. I guess I don't gesture like that, do I? Okay. There's over 30 feet of elevation change of water over a season. This is an unregulated water body, no particular dams on it. So there's a lot in terms of accessibility of making a floating walkway happen, and we had a great engineering team. So one of the things about working on the Eastbank Esplanade was a very serious permitting situation where we wanted to deal with the river's edge and replace these huge slopes of riprap with bioengineering techniques, and also making places for people. So it was really quite a balance of the two systems. And even on the paved portions of the trail, we were looking for small rain gardens, breaking down that runoff into very small increments to be able to clean the water, even though it just goes right into the river from there. And then there was an interesting opportunity for us to do a really big rain garden right beneath one of the freeway ramps. And working with the Oregon Department of Transportation was really interesting. They let us do this, and here's their downspouts right there. And this whole thing is sized large enough to treat everything off of a bridge and these freeway ramps. And they've never disconnected their downspouts. So I'm still working on that. This was opened in 2001. So from there, we started learning more about getting other commissions in terms of, beginning to develop larger visions for what stormwater can do. And this is the Oregon Convention Center. This was early on our idea that you could put an ordinary landscape in here, an ornamental landscape that would be quite lovely and might get it through the design commission, but that we had a bigger opportunity here to really create a vision for treating 5.5 acres of stormwater. So this is the building, this is the expansion, and there's actually 5 different watersheds that work off of this building, and some have to come a long way around. And then they enter a series of ponds down through here. So here's a little rendering. There's an area where they start coming out here, and then there's 9 ponds that work down. There's several different places where the water enters the system. And feeling like the regional plants and the regional stone, the beautiful basalt that we have, could really be featured in a place that visitors and residents come to alike. So this was the largest rain garden that we had done, sort of the biggest disconnect your downspouts project that we'd ever attempted to do. And I think for the most part, it's gotten a lot of good critique. It's been published a lot. A lot of students come and want to know about it. We take tours of it all the time. And our first notion was to run that water away from the building first, because we didn't want any flooded basements. We didn't have any, notion that parking garages, subterranean parking garages would be filled with our stormwater. So we were pretty careful about what we did. But the architects were great about, featuring scuppers, and the stonemasons were wonderful, and you can see the kind of, sort of regional representation that people can learn about the Northwest when they come to a place like this. And almost all of the water infiltrates into the subgrade through these settling ponds, and we really find some of the compositions quite lovely, and there's even more vegetation now in there than there was when we started. And then the interpretive part of it we think is really important so that people learn from this. It's visible, they can see it, but they need to learn. I'm going to move quickly here. We've got a couple of more projects that are in an area called the South Waterfront District of Portland, and there's 2 towers. One's 250 feet on a podium building, and one's 325 on next to 2 podium buildings. And again, the Willamette River is running right here. So this whole district is sort of like Vancouver, BC Point Towers, if you've been there before. Very urban, very tight. How are you going to deal with the stormwater? How are you going to treat that water? And how do you make it visible and appreciated by residents? So people living in these mixed-use towers can actually look down and see or walk by on the street the stormwater at work. And some of it's expressed down at the street level. Some of it's working through a series of green roofs on these podium areas right here. So you don't even need a lot of space all the time. Some of these tight sites are even more fun and more challenging. And there's a stormwater swale all the way along this edge. That's this. And then for people who love water in the summer, which we really don't have, oddly enough, we have about 3 months without water. The residents, were anxious to see some kind of a recirculating water feature. So we don't necessarily, we have them separated as systems, but we appreciate both, and they're handled in a design sense quite differently. And this is out in front of some townhomes. And this is pumped groundwater coming up so the building doesn't turn over when the subterranean water rises. So anyway, there's ways to treat that water as well. I'm going to move through this one very quickly. It was a project that we worked on with Sue Weiler in the room, and a very large green roof cap over a freeway proposal that we worked on several years ago. And this one, I guess I'll just say in terms of the goals of bringing, sort of dealing with traffic, dealing with enticing people to ride more bikes and walk, looking at precedents such as this one in Salt Lake of Olin's work at the LDS Church, bringing these things together and creating a large cap over a freeway was a really interesting design challenge. And putting a piece of art up in the air was pretty exciting too. So this one is not built, but nor will it be. But anyway, it was really a great time to start to integrate these sort of ideas of meadow and ideas of thinner landscape spread out over a cap and a lid over a freeway to really join the downtown of Vancouver, Washington to this park that's across the street. Port of Portland headquarters. If you go in and out of Portland, you will see this building. And I'm sorry, the slide's a little bit dark, but I'll just show you the setting. So here's the control tower. Here's the port headquarters at the airport, Mount Hood and the Columbia River here. And looking at a series of green roofs in terms of capturing that stormwater and treating it in its smallest increment. And that's one of the benefits of both extensive and intensive green roofs. And these are just a few images of how those landscapes have performed and what they're doing. One thing about working at an airport, if you ever get the chance, is the last thing they want is anything flying in the air besides airplanes. They don't want geese, they don't want hawks, they don't want great blue heron, they don't want any of our favorites, and they really dread starlings and birds like that that form big colonies. They call them bird strikes, and you don't want to be in an airplane when there's one going on. So some of the plants that you use to attract wildlife were not things that we used here. Some of the dispersion of planting plan, the way that you would design a planting plan to attract wildlife, has not been used here. And we couldn't use any stormwater treatment that was touching the ground, creating ponds. So we worked carefully with the architects to not only do the terraces on the other side, but this very large, extensive green roof on this side. And all of this really works to try to deal with stormwater, and it's, as again I said, the smallest increment. And this is a recent project where we were on a design team for a pedestrian bridge. And if you've been to Portland and seen the aerial tram, it's right here. And this is right beneath that. And this is a pedestrian bridge that connects down to the South Waterfront district where those other two projects were. And our job, one of our jobs, was to take the amount of stormwater that starts about here and comes off of this deck, which isn't particularly clean because you can see what's going on here. All the particulate from the freeway is rising up off the surface and landing on places like this. So it's pretty dirty water. And when the bridge comes across, and this is just a pedestrian bridge, when the bridge comes across, it's still 60 feet in the air because they couldn't curve the bridge large enough or arch it far enough to be able to meet grades. So one of our jobs was to design a stairway down and work with them on an elevator tower, but also to design a landscape that's very small and is probably one of the most constrained, difficult sites we've ever worked on. And you can see from this closer, there's one of the cabs of the aerial tram. When you come across and you come down the stair, you start crossing a whole series of weirs that are tracing down the slope there. And you can take the stairs or you can take the elevator. And I'll just show you I don't have the ground photography of it yet, we haven't photographed it, but you can see, here's the base of the tram, and then there's these, series of terraces that go down. And this was, we had several alternatives for this. This was an early one where the stair was going to be on this side or that side, and we started, working the plan a little bit more. But it's a really interesting way to experience the water, and it really has a lot of visibility when it runs. It moves through the system fairly fast. There's not a lot of retention, but it's really kind of a fun project. And then lastly, the Bud Clark Commons is a new building in downtown Portland right near the train station, a transit mall that is built for three purposes: to provide day services to the homeless, and then there's a men's shelter where homeless men can come and live for 90 days while they're looking for work. They have to be clean and sober. The ones walking into the day center, you can imagine, in all kinds of states of mind and states of physicality. And then in the top area, they rent out single studios to very low-income people or no-income people. And you're probably wondering why I'm showing you a project like this, but our design for the day center is right here. And we designed it sort of like an outdoor room where people come in, they queue up in this space, and they walk through the gate. Here's the entry gate, and they can put dogs or bikes or possessions in lockers over here. And then they come in and get a number underneath that canopy, and they reside in this courtyard to wait for services. So they might need to make a phone call, they might need a shower, they might need to develop a resume, they might need a form of ID. You can imagine all the kind of misfortunes that have come upon people who are coming to this facility to try to make a change in their life. And this is LEED Platinum, and we had a great team of architects and engineers who wanted us to work quickly on excuse me, I'm trying to speed my presentation up, how we could integrate stormwater and stormwater treatment into the building. And there's one area, there's a green roof underway right here, and then there's another courtyard component right here that has stormwater in it, and then down, I'll show you this courtyard where the water also drops down through. So part of this is the area where the stormwater is coming through, getting treated by plants. And then I just wanted to show you this, that we work carefully with an artist that does stonework that developed these splash blocks for a series of pipes that, release the water into the planter. So this gives you an idea of what kinds of facilities you can put out there giving, attempt to give some dignity and respect to people who really are trying to make a change in their lives. And also, I was asking Steve earlier about the acoustic qualities of the space that he designed at 10th and Hoyt. And it's really interesting to introduce that in there because from a seasonal standpoint, you're getting this play of water into these small private spaces, and it's really quite an effective tool. And it's had a calming influence. The people who worked there said the group sort of comes in and they don't fight, they don't have as many conflicts as they otherwise might. They seem to sort of have a meditative atmosphere created for them, which is very helpful if you're trying to make a change from life on the street. So with that, if you have a chance, we just launched a new website on Monday. It's got a few wrinkles on it still, but there's a whole lot more on stormwater and green roofs on the website. I'd be happy to take questions.
Thank you, Carol. Will you just expand a bit on how your knowledge or thoughts about the flow and transport of these contaminants have been built into your designs?
Well, I think, frankly, there's a lack of, Tom may be better equipped to address this than I am, but at least for us, there's sort of a disappointing lack of follow-up on these projects to be able to put some metrics to what it is that's coming in and going out. And I'm hoping to get one of the graduate students at the University of Oregon to start doing monitoring on the rain garden at the Oregon Convention Center. So that's something that I would love to know. But just in terms of empirical, evidence and looking at it ourselves and mucking around in it with the, people who maintain these places, what we've noticed is the more point loading that you do, there's going to be a pile of particulate. Just like in the first picture of the Grassy swale, you'll start seeing pockets of this stuff building up. If you're spreading the flow out, as Kevin said, you're going to get less of that sort of concentration. And I think the plants in the soil, bacteria in the soil, are more apt to process those contaminants than when they're point loaded in a little pile. So the other thing we've learned is we get sort of this urban, I don't know what you would call it, it's sort of like a dried algae moss stuff that sticks to surfaces. Sometimes we find it best to make a waterfall as opposed to something that the particulate is going to stick to, but it starts to create algae and moss on it, and pretty soon you've got sort of this growing medium of stuff that, I'm not sure it's good. It's urban particulate that, if I were a scientist, I'd love to really find out what's in that. So I think there's a lot of work to be done in those areas. Yeah. Nope. Okay. Oh, Tom, please.
So with regard to the question of pollutants accumulating, the city of Portland has done a lot of research with regard to that question. And so soil samples are taken in numerous facilities around the city, and then a criteria is used that is considered what the various constituents and their relationship to the safety of children who might get into a facility. And to date, they haven't found anything that exceeds that level that's safe for children, but we are doing more and more streets. And so in some of them, it appears that you can see some, in Portland anyway, some of the streets, you can see some locations where there's a really high concentration of an amount of water that comes in, as well as the constituents that are in that water. So I'm a little concerned about some of those larger high volume street conditions as to whether that remains the same with regard to the safety of children. So if you're in an industrial area, then the criteria is even different. So it's not to say that that's the answer, but there's work being done, at least in the city of Portland.
You know, the water, stormwater, is not the problem. Stormwater is only conveying what the problem is.
Yeah.
The pollutants are coming from a different source. So when we talk about point source solution with stormwater, it's not the water. It's what's coming into the water that is the issue.
Yeah.
And a large part of that is, and Carol, you had listed the load of contaminants that are coming from primarily vehicles that are getting into the water itself. So I guess my thought is that you know, we are doing the right thing about trying to create a more natural system, allowing that water to move into the ground. The next step is now to look at where the true source of the pollutant load is. And I would almost put out a challenge to major car companies. You're doing a great job with energy and looking at ways to improve the efficiency with the vehicle. Maybe now it's time to look at the car from this other viewpoint of pollution, not air pollution, but water pollution, and looking at designing and materiality that lessens that burden on the stormwater. Because again, it's not the water that's the issue, it's the stuff that's getting into the
What's
water.
the oils, you know, the lubricants and the
Yes.
rubber off the tires. That's why you have to buy tires every so often.
Thank you, Carol.
Thank you.
Great session, great question.